So today, to cover the agenda, we're going to be going over Azure Monitor. As you know, we'll be discussing what it is and how it can help you on a day-to-day basis as an IT professional. We'll touch on some best practices and guidelines for implementation. In order to do so, we'll be breaking Azure Monitor down into four core areas, data collection, data visualization and analysis, data response, and data integration and export, both within Azure and a third-party application. And finally, we'll touch on the Azure scaffold and how Monitor fits into this concept. And after the presentation, during the poll questions as well, hopefully I can have some time to answer any questions that you have. I'll be sure to leave a little extra time at the end for the poll as well as the questions. So jumping right in, first and foremost, we'll tackle some basic questions. What is Azure Monitor? Why should I care about this feature? And really, what does it do for me as an IT professional? So Azure Monitor is defined by Microsoft as a way to maximize the availability and performance of your applications by delivering a comprehensive solution for collecting, analyzing, and acting on telemetry data from your cloud and your on-premise environments. It allows for full stack visibility with visualizations, alerts, and/or automations into your applications hosted in Azure, your IT infrastructure, both cloud and on-prem, and your network. This visibility allows for intelligent insights into your environment by automatically identifying and predicting anomalies in your data to quickly alleviate or even prevent issues. Not only does it help by lowering anomalies, but it also tries to optimize your environment by determining areas that can be improved across your architecture as a whole. And finally, Azure Monitor is open and extensible. It contains many out-of-the-box integrations with countless other possibilities available with some customizations through its API. This is especially helpful if you already have a third-party SIM or ITSM tool, and you're really not looking to replace this investment at this time. Azure Monitor data can be piped into that tool in which you already have current investment. Azure Monitor does these things by providing visibility into the following four key areas. First and foremost, activities. Who is doing what within your Azure and resources themselves? Performance metrics. So that's the execution of your Azure resources. Is it up to par with your expectations? The health of those resources. Are there any optimizations that can be done to increase the usability of your resources? And finally, availability. Is there anything that can be done to increase the uptime of your resources? Monitor collects two main types of telemetry data to get this visibility. First is metrics, which are numerical values that describe an Azure system at a point in time. Whereas logs are different types of data that can be organized into records of varying properties that aren't necessarily numeric. And we'll talk more about this key difference later in the presentation. So as mentioned in the agenda, we'll be breaking down Azure Monitor into four key areas. First is collect. So how do we gather the data that is used in Azure Monitor? Visualize and analyze, making sense of that huge amount of information collected by Azure Monitor. Third is respond. Now that you've been identified or notified of an issue, what do you do about it? And fourth, integrate and export. What other workloads, both in and out of Azure, can use Azure Monitor data? We'll be doing a deep dive into each one of these four sections throughout the presentation, starting obviously with data collect, which is a natural place to start as Azure Monitor needs to get that data before it can empower the rest of the steps. So with that, let's begin with the first of the four steps, data collection. In this section, we'll discuss what type of data Azure Monitor collects, the detailed difference between metrics and logs, as we already sort of touched on, and the retention of this data to ensure the availability of the service. So first, what type of data does Azure Monitor collect? Azure Monitor collects operation, management, health, and performance data on five key areas. The Azure tenant as a whole, so the entire overall tenant, items like Azure AD logs, administrative logs, RBAC or role-based access control logs, all of these things at the very top level. It then goes one step deeper into Azure subscriptions, so information on each individual subscription that you have in your environment, to billing information, connectivity, service health, etc. Next is Azure resources themselves, so information about the resources you have deployed in Azure, such as app services, VMs, networking, etc. Then it also actually goes into the application layer, so data from your applications that you have deployed in Azure, your code and your app services, the code that you have on those systems. And finally, guest operating systems, logs coming from the virtual machines you have deployed in Azure, another cloud service, or even on-prem. So resource subscription and tenant monitoring track data about the framework itself, each covering items such as created date, modified date, the last modifier of those resources within your Azure environment. Platform independent application data is then collected to describe the performance of the code you have running in Azure. And guest OS data is collected to give specifics around the types of virtual machine operating systems you have hosted in your Azure environment, another cloud service, or even on-prem. I think that's an important item to make note of, is the ability to mix cloud and on-premise guest operating system data. This allows for a single pane of glass into the health, operation, management, and performance of all of your resources, regardless of their physical location. It could be on-prem, it could be in Azure, or it could be in another cloud service altogether. So Azure Monitor data is being collected in two forms, metric and logs. We touched on that previously, and we'll kind of do a deep dive of the real difference. So metrics are numerical values that describe an Azure system at a point in time. It's known for being lightweight and capable of near real-time reporting. Using the Metrics Explorer in Azure, shown in the upper left, you can easily graph these metrics over time to see trends and outliers in a more visual manner. Logs, on the other hand, are different types of data. They're organized into records of varying properties. They're not necessarily numeric. This data is usually telemetry data like events or trace logs. Using log analytics on the upper right, you can query this data to uncover patterns or outliers in your data. Like the Metrics Explorer, this data can be turned into a graphical format for easy reporting, and we'll talk a little bit about that in the visualization section. So shown here is a blown up view of the visual created with the Metrics Explorer, showing the trend of average CPU percentage across time on two separate instances in Azure. Graphs such as this one is easily generated in under a minute and can be pinned to your Azure dashboard for easy visibility. Graphs can be the foundation for giving an alert, giving you visibility into where you really like to place a threshold. You want to make sure you don't have your threshold too low, because you'll get into a boy who cried wolf scenario. If it's too low, it's hitting all the time, you're getting an alert all the time, you just tend to kind of ignore it because it's not that big of a deal. You don't want the threshold too high either, because you're missing out on an alert that you really should be seeing. In this case, perhaps 30% is a good number, as it only hits once in this day range that's shown. However, this decision really should be determined only after you ensure you have a properly sized machine in the first place. Perhaps what this graph is really showing you is if you're not comfortable with that idle CPU time hovering around 20 to 30%, maybe you want to up that CPU cores on this instance or these instances. Similarly, here's an example of log analytics using the query language to display relevant log events for troubleshooting and alerting. Notice that this data is more textual. It's not necessarily numeric and therefore isn't graphed by default. However, it can be graphed to show the count of errors, the average number of errors per day, average time of errors, and many other items. These results can be also pinned to the dashboard and can be the foundation of alert rule for those same reasons we discussed in the last slide. And we'll touch on more of that in the visualization section as well. To kind of summarize the difference between metrics and logs, I created this table that I think does a pretty good job of comparing the two. Benefits of metrics are they're lightweight and capable of that near real-time reporting, whereas logs are more for deeper analysis, trying to see what went wrong on a system and kind of digging into it deeper. Data in a metric is numeric only, whereas in a log it can be textual or numeric. The structure of a metric is a standard set of properties that Azure defines, whereas in a log, the properties can vary depending on the type of the log. Data collection for a metric is at a very set regular interval, whereas a log, it's sporadic based on as events trigger. You view metrics in the Azure portal with the Metrics Explorer, whereas you view it in Log Analytics for logs. And data sources for metrics include platform metrics from resources in Azure, applications with application insights, which we'll touch on later, and even custom defined by an application or an API that you define. And for logs, it could be application or diagnostic logs. It could be a monitoring solution, actually including Azure Monitor itself, so you can pipe all of a metric into logs to kind of have them in a one single view. They can come from agents or VM extensions, as we talked about with the guest operating system. Application requests or exceptions, Azure Security Center, which we'll touch on a little bit later in the presentation as well, or through the Data Collector API. So talking about retention, I think it's critical to consider retention when preparing for a successful Azure Monitor implementation. Both metrics and logs are retained by default for a set period of time. It's relatively low cost to extend this period. However, it's important to optimize your retention, so you're really only paying for the storage that you need to use. Also, retention too long is adding unnecessary hay to the haystack when you're trying to find that needle. Metrics are available for a 90-day period at no charge. This is expandable, of course, and logs are retained for the first 31 days at no charge, up to an infinite retention. Data can be routed to a storage account in Azure, an expanded retention log analytics workspace, or an event hub to be piped into a local tool. Keep in mind as a disclaimer that Azure pricing changes very frequently, so it's best to check to their pricing page and calculators for specific details on all the topics that we cover. So now that we've covered how Azure Monitor collects that data, let's discuss how you can visualize and analyze the data. Here we'll be talking about how to make this flood of data consumable in order to make some intelligent decisions based on the data to either save money, increase performance and availability, or even drive off some threats. So visualizing data in Azure Monitor comes in three main forms, including views, which is good for lightweight visualizations, usually of a single or a small number of resources. Dashboards, to make comparisons over a larger amount of resources or to continuously monitor something. And Power BI for the most advanced visualizations. So starting with view, you can see an example of a view on the screen. Advantages of views is they allow for some rich visualizations for log data. You can export and import them to move them around to different resources. You can integrate with Azure itself. So you build these views and you view them in Azure. And they're interactive. It allows for multiple level drill in, drill down, drill through, etc. Some limitations is it supports logs, but not metrics. There are some workarounds to this. As I mentioned, you can actually pipe all of your metrics data into logs, but it doesn't do it out of the box. There's no personal views, so every view you create will be available to all users within your workspace. There's no automatic refresh, so you'll have to constantly refresh the page or just go back to it and check on it. So it's not meant for a dashboard. There's limited layout options with the view. You're kind of limited to these columns you see. There's no support for querying across multiple workspaces, so that's why I mentioned it's very, very resource specific. And the queries are limited to 8 megabytes or 110 seconds execution time. Dashboards, on the other hand, as you can see on the screen, have a number of different use cases. Some advantages are you can actually pin a dashboard to your Azure dashboard and see it kind of overall as soon as you log in. This does support both metrics and logs out of the box, which is quite handy. You can combine data from multiple data sources, so you can get an overarching view of multiple resources, multiple groups, etc. You can have a personal dashboard or a shared dashboard, depending on the use case. And it's integrated with Azure role-based access control, so you can really define who has access to modify your dashboards and view the dashboards, etc. There is an automatic refresh with the dashboard, so it's ideal for leaving it on a screen if you want to continuously monitor something. Metrics refresh at a minimum of 5 minutes, whereas logs are every minute. There's more flexible layout options. So each one of these tiles you can move around and arrange how you want and size them differently. And there is a full screen mode available for dashboards. Some limitations are you have limited control over the visualizations in each tile themselves. Log charts are limited to 30 days, so you can't go past that with a dashboard. Log charts can only be pinned to shared dashboards, and there's limited drill down and interactivity with dashboard data. It's meant to be a single view instead of an interactive. And finally, Power BI, which allows for the most advanced types of visualizations of all of this data. So advantages are that most advanced, the rich visualizations and interactivity with drill downs, drill throughs, etc. It's easy to share Power BI data throughout your organization, and you can integrate it with a number of separate data sources. Also, an advantage is performance. You'll see a higher performance with Power BI. Limitations are it supports logs, but not metrics. And again, there's a workaround, but out of the box, it supports logs. You can't manage dashboards and models with Azure itself. This is a separate tool, which isn't necessarily a limitation, I guess, but you don't have that single place to go. And there's also limitations on the data result size and refresh rate, depending on the version of Power BI you have and how you're implementing it. So now that we've visualized and analyzed this data into some meaningful visualizations, let's discuss on what you can do with this data. How do you respond to the items we identified in that previous step? So visualizations are great, but it's really only half the story. Now that you know there is unwelcome patterns or unwelcome outliers, what do you do with that data, and how do you avoid constantly checking your dashboard? The answer is alert logic. So Azure Monitor has alert logic built into the platform. The graphic you see on the screen shows how alert logic workflow helps limit the amount of effort you need to put into Azure Monitor to gain those desired returns. Azure alerts start with a record, either a metric or a log, that is stored in Azure Monitor. An alert rule created by you with thresholds that you set analyze the log storage environment waiting for a trigger. Once the alert rule identifies an event that surpasses that threshold, the alert trigger is activated in one of two ways, either an automation and or an alert. These alert triggers are organized into an entity called an action group. Action groups are a way to organize your triggers into meaningful and reusable segments. You can set alert and automation actions inside of an action group in order to reuse them in the future. Required fields for an action group include name, short name, its subscription, and resource group for it to live in, as well as the type or types of actions you would wish to perform, including a notification either by email, SMS, push notification if you have the Azure app, or voice call. You can also do some automations like an Azure function, a logic app, a webhook, pushing it to ITSM, or an automation runbook. One best practice to keep in mind with an action group is to keep the scope of the action group isolated to the resource group that it lives in for efficiency purposes, and also reuse action groups as much as possible. If you're going to do the same email, the same logic app workflow, reuse action groups to keep the overall number of action groups limited. So the two options you have for actions with an action group, we'll start with alerts, which is an excellent way to be able to be notified on a set of criteria without having to constantly live in the portal and watch your created visualizations and see if something spikes. Metric rules allow for real-time reporting on numeric values, whereas the log rules allow for more complex logic across multiple resources. Options for alerting is quite extensive. It allows for email, text, as we mentioned, push notification, and voice. And that's all out of the box. If a trigger happens, you can pick one or more of those. They can be mixed and matched as well, both multiple techniques and multiple people or groups being notified. The other half of alert trigger is automation. If you find yourself going into the system and always performing the same set of steps each time you get an alert, maybe you just want to convert that to an automation and avoid having to go into the system altogether. Automation exists in the following formats: Azure Functions, Logic Apps, Webhooks, ITSM, and Automation Runbooks we mentioned. As shown in the image, if you get an alert, every time you get that alert, it says, hey, the CPU or the processor time is greater than 80%. If you do that, you go in, you add another virtual machine, If it does it again, you go in and add another virtual machine. This is a perfect use case for countless others to create an automation to reduce the effort you or your team needs to expend in the system. And this workflow also has caps to ensure that your costs aren't outrun as well. So in this example, the maximum is 5, and then perhaps maybe an email alert is sent for approval to go beyond that. Similarly, when the load is slower, the automation can trigger a descale of the environment going back to 3 or back to 2 or even 1 to reduce your costs. Microsoft likes to call this right sizing, and it can be done automatically without effort from you or your team. And finally, we're going to discuss the last stage of the 4-step breakdown, integrations and export. So here we'll be answering the question, how can this data be used outside of Azure Monitor? And also, how can we integrate this data with other solutions inside of Azure? To get data out of Azure, integrations lie in 3 main areas: event hubs, logic apps, and APIs. Azure Event Hubs are ideal to be used as a streaming platform that's perfect for streaming that data out of Monitor and into a third-party SIM tool or another monitoring solution altogether. Azure Logic Apps can be used to build much more advanced workflows and automations from within Azure, but can also allow out-of-the-box integrations with a number of third-party systems. And from there, Azure Monitor data is accessible with an API to enable countless other custom integrations as necessary. So we discussed how we get things out of Azure and out of Azure Monitor, but now we'll talk about how we can integrate with the things that are already in Azure itself. The image you see on the screen shows the Azure workloads that are associated with monitoring. Up to this point in the conversation today, we discussed the items highlighted in red. The rest of this section, I will touch on the items we have yet to discuss, which I've highlighted in yellow. Application insights, getting the application data into Azure Monitor, infrastructure monitoring and security, the Azure Advisor, and Azure Service Health. And we'll start with application insights. Application insights is one of the Azure workloads that can be integrated with Azure Monitor, and it focuses on your application layer to help analyze and monitor the code that you have deployed in your Azure workloads themselves. Telemetry events from the code that you create in Azure can be piped to application insights, and Azure can then intelligently analyze, visualize, and respond to those trends and or events in the data in the same forms that we discussed previously. So those visualizations, alerts, and automations, but the data is coming from your applications themselves, your code. With infrastructure and security monitoring, it's another huge opportunity of integration within Azure. Items such as the Network Watcher focuses on your network layer in the Azure environment, as well as the connections to your on-prem environment, enabling packet capture, next hop, IP flow verify, and NSG flow logs. All of these items can be integrated with Azure Monitor to then trigger some sort of alert and or automation, as we already covered. Additionally, and similarly, the Security Center focuses on the security layer of your Azure resources, network, and partner solutions. Events in the Security Center can have the same alert logic and Azure Monitor enabled to properly alert your security staff on potential risks, attacks, or gaps. So another really big area of integration is Azure Advisor, which I wanted to take a minute to talk about today. Microsoft defines Azure Advisor as a personalized cloud consultant that helps you follow best practices to optimize your Azure deployments. It analyzes your resource configuration and your usage telemetry, and it basically recommends solutions based on that data in 4 ways. First is high availability, to ensure and improve the continuity of your business critical applications. Security, to detect threats and vulnerabilities that may lead to potential security breaches in the future. performance to improve the speed of your applications, and cost to optimize or reduce your overall Azure spend. And best yet, Azure Advisor recommendations come at no additional cost and provide actionable results with, in many cases, step-by-step instructions and links on how to implement the suggestion. Azure Advisor runs separately on each subscription in your environment and can be turned on and off for specific subscriptions or specific resource groups. Azure Monitor can be also enabled to help you send alerts on these recommendations, keeping you up to date without having to constantly check back to the section. And finally, we have service health. It's a great way to gain visibility into the health of Azure itself, and this is coming from Microsoft. So service issues, planned maintenance, advisories are all given in this area to give you visibility into items that are out of your control and in Microsoft's hands. This section includes workarounds, estimated downtime, and many other details that will be very helpful in the event of an outage at a Microsoft data center. This data can then be alerted on, and automation can be enacted in Azure Monitor, which I think is super important. So for example, if there's a service issue posted for the East US data center, there's something going down with it, you can automatically enact an automation that fails over to your West US data center, and then you can alert the IT leadership team that this has happened and make some steps for when that needs to be remediated. So before we end, I wanted to keep some time for questions in the polls as well, but I'd like to cover an offering that Pragmatic Works has that takes all of the things we talked about and much more into account. It's called the Azure Scaffold, which is a Microsoft term that sets up the framework for Azure architecture, but can also help you validate the current architecture that you do have if you have any set up currently. Monitoring and alerting is just one section of many sections here. It's step 7, you can see in the highlighted section. Other topics, I'll do a brief rundown on what we do in this initiative. So step 1 is governance, or building that foundation for your Azure environment. 2 is hierarchy definition. So your subscription counts, your resource group counts. Do you need multiple tenants, resource tags? All of those things are discussed in this section. Step 3 is naming conventions, so determining what your naming of resources, subscriptions, etc. should be. 4 is policy and initiatives to manage your risk and enforce some rules in your environment if you only want a certain tier of VMs to be able to be created, something like that. Step 5 is identity and access, so controlling access to your Azure environment and your Azure resources. 6 is security, or protecting your Azure resources. 7 is what we talked about here today, monitoring and alert. It collects, analyzes, and sends telemetry data. Step 8 is cost management, so optimizing or right-sizing your environment, making the most of your investment in Azure. Step 9 is automation and DevOps, so saving time and limiting mistakes by making items reusable, repeatable, and putting them in templates. And step 10 is the core network, so ensuring effective and secure data transfer between your on-prem environment and Azure and within Azure itself. And all of these things are tailored and customized, company specific. So we really go into detail about what your monitoring plan is and how that can be adapted in Azure, and what your naming standards are and how that can be identified in Azure, etc. And with that, that's really all I had today. We're right on the 30-minute mark, a little bit over because I reset it when I started recording. So I think that's pretty good. Thank you for joining today's session. I hope you're able to take something away to help you better manage your Azure environment. And
let me go ahead and turn it over to you, Josh. Josh, can you see the questions, or do you want me to read them off for you?
I got it. I think I can take it for you. So first, I see a question from Miguel. Can we use Azure Logs with Splunk? Absolutely. I've done this myself actually a number of times. You can do either way. So you can actually send Azure Logs to Splunk, or you can send Splunk logs to Azure Monitor. Obviously, you want that single pane of glass. You don't want to have to check Monitor and check Splunk in order to get to the bottom of something. But either way is possible. You can take those Azure Logs and dump them into your Splunk environment, or you can do it the reverse. You can take your Splunk logs and upload them to Azure Monitor, or both if you really wanted to. Gary said, how do you access Azure Monitor? Great question. Azure Monitor it's collecting data. If you have an Azure tenant right now, it collects data on all of your resources by default. So if you go into the Azure portal, portal.azure.com, and you go to the top search bar is probably the quickest way, and just search for monitor. It's one of those applications you'll see in that screen. You can also get it from the all resources screen. You'll just have to scroll through and locate it. Simon says we have Azure AD. Can we use Power BI to capture the accounts in computer OU not being used for the last 3 months, or do we have to use Azure Monitor? Great question. There's multiple ways to do that. You could use like the Graph API to pull the usage and stuff like that, but you can use Monitor data to do that and visualize it in Power BI. I would definitely look into Azure Monitor and see if it contains all of the parameters you're looking for, specifically at the tenant and the subscription level, more specifically the tenant level, because Azure AD logs are stored there, which may include some of the information you're looking for. You also mentioned down below, we have Office 365 for students as their emails. Please advise a tool or a way to capture email utilization. Again, Power BI may be an option for you at the Azure AD level, so the tenant level, the top level that we talked about. If you go into Azure Monitor, you'll be able to scroll through all of the things that are being collected by default, but you can write a custom API, including the Graph API, to capture utilization, pipe that into Azure Monitor, and then easily visualize that data with Power BI. And you mentioned the subscription for Azure Monitor isn't included with Azure AD. It's actually separate from Azure AD. Azure Monitor pricing is a little bit different. And another question just popped in about how you find the pricing model. The pricing page is on their website, and they actually just updated pricing last month, which is why I didn't include any slides or anything with it, because they just changed it and I didn't want to say the wrong thing. So definitely go to Microsoft's website. If you just search for Azure Monitor pricing, the first link will pop up, will be it. And it really it describes how their pricing works, because it's a little bit different. You have to pay for the storage that you're using, which is quite minimal, and then you also pay for the alert aspect of it. So when an alert triggers, there's a pricing for how that alert is handled. So definitely check out that website, and it gives you a table and breaks it down pretty simply, much better than I can do on the call here today. I don't want to skip Steven. Steven said cost should be added for concerns. I agree with that, actually, Crystal. I think that's what I would have said on one of those poll questions. Cost is something that I think people fear when moving to the cloud, and analyzing that cost and how to right size the environment and optimize cost is something that I think I hear a lot. So I agree with you on that one, Stephen. Dale was talking about the poll. We have pricing model, so I talked about that. Definitely search for the pricing model online. The storage has a minimal cost, the alerts have a cost, and all of that together. There's a calculator online too to really get a feel for what that will cost. All the customers and people that I work with in this area are surprised by how little it costs. I will say that it's not a gigantic cost, all things considered. And I think the cost benefit is definitely pretty high. So you don't have to constantly be checking in the portal to see if there's some sort of degradation. You can just wait until you get an alert, or have an automation take care of it for you and completely keep it out of mind. Power BI connected to blob storage is good practice for monitoring dashboards. Yes, so that's perfect. That Power BI connected to the blob storage, as you're talking about, is good practice for monitoring dashboards. Yes, you can have your Azure data piped into that blob storage to augment that reporting or that monitoring. So you can actually take all the data we talked about today, pipe it into blob storage, and have Power BI use it to augment the data you already have in there, coming from things like the Azure tenant, Azure AD, all the Azure resources, etc. And Simon, thanks for the answers. Absolutely. This is one of my favorite parts of the webinars. I love answering the questions and kind of seeing where you have questions and thoughts on the presentation and everything like that. So no worries at all. I definitely appreciate all the questions. If there's any more, we have some time left. I wanted to have some time left over for them. Otherwise, thanks everyone for joining today. I definitely appreciate it. If you have any questions, feel free to contact us, and you can get in touch with me even directly if you need it, and we can chat about where you are in your cloud journey and how monitoring and alerting can be a fit in that.
All right, thank you, Josh. And sorry guys about all the poll mix-ups and the questions. It's a little lagged here, but we apologize for that. But Josh, thank you so much for hosting. If you guys don't have any questions, or if you guys have any questions that you think of after this webinar, please feel free to reach out to myself or Josh. We'll be happy to help. The next webinar will be on Tuesday, and then we have another webinar on Thursday. So please don't forget to check the site. This is recorded and it will be sent to you tomorrow via your email. So if you guys, like I said, if you guys have any questions, please feel free to reach out. Josh, again, thank you so much for hosting, and I hope you all have a wonderful day.
Absolutely. You too, Crystal. Thanks, everyone.
All right. Thank you.